This video is going to go through a couple more examples of drawing orbital diagrams and writing electron configurations. The rules for the electron configurations and orbital diagrams really aren't that complicated. I think sometimes what gets in the way are the symbols. So this slide goes through those symbols again really quickly. Um, Again, the electron configuration consists of three parts. It tells you which energy level the electron is on. It tells you which sublevel it's in. So at each energy level, there can be sublevels that require slightly more or less energy for the electrons to reside there. And you also then have a superscript that tells you the number of electrons in this sublevel. And if we look at the orbital diagram consists of orbitals, or the places where you're likely to find the electrons. Each box represents a different orbital. And then you also have sublevels, and these sublevels are separated by a space, and the S sublevels only require one box because there's only one possible location for electrons at an S sublevel. But if we look at a P sublevel, there will always be three boxes because the P sublevel has three places where the electrons can be found, therefore three orbitals. And then if we go down here to the D sublevel, anytime you see a D sublevel at any energy level, 3, 4, 5, 6, or 7, there will always be five boxes to represent the five orbitals or locations where we might find electrons. And then finally, underneath each box, we have the notation that we're going to use for the electron configuration, and this is called the filling order. I will always give you the filling order. It's either on your periodic table or it will be given to you in the question, and I will always give you the boxes for the orbital diagram. All right, so the rules are pretty easy. First of all, how do you know the number of arrows to draw or the number of electrons to put into the superscript of the electron configuration? You use the atomic number. We're always going to write electron configurations for neutral atoms, unless you're told that it's an ion. And the atom has a characteristic number of protons called the atomic number. And in a neutral atom, the number of protons and electrons is equal. So if we look up the atomic number, we'll know the number of electrons, therefore the number of arrows to draw. The filling order, we're always going to start with the lowest energy first. So energy level 1 is the lowest. And in this horizontal version, we're going to just work our way from left to right. We always put the up arrow into the orbital first, and then if we have more arrows to place, if the orbital is not filled with 2 electrons, we'll go ahead and put a down arrow. For the s orbitals, that's easy. We'll just go ahead and put an up and a down and an s orbital. It's when we get to the p orbitals, so here's 2p, here's 3p, here's 3d, where we have more than one orbital at that sublevel or more than one box. We're first going to place the up arrow into each box before we go back and double up. We called that the bunk bed rule when we were using the POGIL activity. All right, and then one more rule, and that is that the arrows in each orbital have to be in opposite directions to represent the opposite spins or magnetic fields that the electrons need in order to be able to exist in that orbital. With the orbital diagram and electron configuration for boron. So boron is number 5. We know it has 5 electrons, and we start on the left side or the lowest energy level, and we go ahead and put 1 electron into that first orbital. It's not full, So we can add a second. So I'm going to go over here and grab 2. And when I put that in there, it just covers up that first electron. And now we've got a total of 2. Okay, so now we can move to the next sublevel, and that's the 2s orbital. Again, we'll put in 1 arrow. It's not full, so we can double up. And now the 2s sublevel is filled. The next one we're going to go to is 2p. And again, we always start with 1 electron in the up direction, and that gives us our 5th electron. And so we're finished with boron. Now we just need to fill in the electron configuration. Once we've got the electron placed in the orbital diagram, the next part's easy, because all we have to do is use the notation under each box. And the only thing we have left to do is to count the electrons at each sublevel to replace the subscript. So 1s2 is already written. So 2, and then I will tab over to s, and then tab over, and there are 2 electrons in the 2s orbital. So the superscript is 2. And then I have an electron in the 2p sublevel, and I'll tab over, and I see 1 electron there. And so this completes the electron configuration for boron, which has 16 electrons because it's number 16 on the periodic table. I'm going to show you a little shortcut for this one. It's important to put the electrons in up and then up down for each sublevel so that we make sure that we're following Hund's rule. But when we have lots of electrons, like sulfur has with 16, sometimes it's easier just to go ahead and fill orbitals with the up-down arrow to begin with. So the way I know whether I can put them into the orbital as the up-down to start with, or whether I need to put them in one at a time, up arrows first, I simply count to see which sublevels I can completely fill. So as we start counting, here's 2, 4, 6, 8, 10. I still have plenty of electrons, so I know I'm full up to there. And then at 3s, that would be 12. And then we get to 3p, 14, 16, 18. We would need 18 electrons to fill up 3p. So once I get to 3p, I'm going to have to put them in one at a time. I know everything up through 3s is filled. 2, 4, 6, 8, 10, 12. And I know I have 12 electrons. But once I get to 3p, 14, 16, 18, I don't have enough to fill this one up because I only have 16 electrons. So this orbital, I will put them in one at a time. All right, so let me go ahead and move these over. There's 10, 12, and now I know at 3p I need to put them in one at a time. So there's 13, 14, 15. I need one more, so that means I can double up. So let's bring this one down and cover up that first up arrow. So there's my 16th. Let's just double check. So we've got 2, 4, 6, 8, 10, 12, 14, 15, 16. So now it's just a matter of transferring that notation down here. 1s2 is already done for me. So 2, then I'll tab over to s, and I can see I have 2 electrons there. Whoops, I didn't tab first. There we go. And then I move over to 2p and 2p, and I can see there that I have 2, 4, 6 electrons. And then in 3s, I see 2 electrons. And then finally we are at 3p, and at 3p, 2, 3, 4. So this is the electron configuration for sulfur. All right, let's try one more. And this is cobalt. Here's where it's going to be really nice to just put in the doubles right away. So cobalt has 27 electrons. So I'm going to see how far I can go before I need to put them in one at a time. So 2, 4, 6, 8, 10. I've got enough to fill that. 12, 14, 16, 18. Plenty to fill up 3p. 20, plenty to fill that up. And then 22, 24, 26, 28, 30. I would need 30 electrons to fill up 3D. I don't have 30, so I'm going to put them into 3D one at a time. All right, so let's go ahead and fill the electrons. 2, 4, 8, 10, 12, 14, 16, 18, 20. Okay, now I know I don't have 10 more to completely fill 3D. I'm up to 20 when I get to 4S. So I'll put in one at a time. There's 21, 22, 23. Whoops. Let's grab the electron there. 24. There's 25. Okay, now I can double up. So there's 26. And here is 27. Okay, I'm covering up some of the lines. If you do that, don't worry about it. I'm just going to move these so that you can see the delineation between them. All right, so now all I have to do, I'm going to double check 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, 26, 27. So I've got the correct number. So I will come down here and just duplicate the notation. Oops, again, I forgot that. Here we go. Tab. Three P, and I see 6 again. For S, there's 2. And the last electrons are in 3D, and we have 7 there. So this is the electron configuration. And again, you can check your electron configuration, first of all, by making sure that all of the notations fall in the same order as the filling order. And then you can determine how many electrons by adding together the superscripts. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, there's 20, plus 7 is 27. So I have the correct number. This is also the way you can work backwards. If you see the electron configuration, if you add up the superscripts, that'll tell you the number of electrons, which tells you the number of protons, which tells you the atomic number to look up on the periodic table.